These days, we are using lots of electronic devices in our daily lives. I use devices like phone and tablet, and I have to charge the battery every day. I think that battery charging is one aspect of power electronics.
I think power electronics is related to adapted circuit that change wall power into power that we use for devices like laptops, and circuitry in the power adapter makes sure that power is delivered safely to the device, that it doesn't break or overheat.
So what is power electronics? As we've heard from the student interviews, there are lots of examples in our daily lives. Generally, we think of two things. We need to have a source and we have to have a load. The source is something that generates power. So for example, it could be a battery or your wall power. The load is something that consumes power. So it could be your computer, your TV, other types of devices that you use in your daily life. The power electronics is the technology in between. It's a circuitry that takes power from the source and delivers it to the load. For a very broad definition, we can say that power electronics is the application of electronics and circuitry to control the conversion of electric power from one form to another. In the next part, we'll look at a few examples of power electronics. There are many examples of power electronics in our daily lives. Let's look at a few examples. First, we'll start with a notebook charger. So here, in this case, we have a source. The source would be the AC power grid. The load would be your laptop that you connect through here. Specifically, we'd be using the power from the wall to charge the battery. And the power electronics are all located inside this block. Let's look at another example. Here we have a portable battery pack, and usually you have to charge this up first. So when we're charging this battery, the source is USB power, maybe from your computer, and the load is the battery pack. The power electronics and the battery pack are both located inside of this pack. For another example, we'll look at a little bit larger power. Here we have a photovoltaic solar panel that is powering the AC grid. So in this case, the PV panel is the source, and the load, we need to put that power to the AC grid, so the power grid is the load. And we have the power electronics in between them to transfer the power from the PV panel to the power grid. The last example is a wind turbine. So this is a larger power example. Here we're taking wind power and changing that power through a motor into electrical power. As the motors spin, we generate power. We want to send that power to the power grid, the electric grid. So our electric grid is our load and our source is the turbine. The power electronics is located within the turbine to connect and allow power to flow from the wind turbine to the AC power grid. So we've learned today that power electronics is all around us at different parts of our lives, and we've defined what power electronics is and given some examples of various sources and loads. So through this, we've shown that power electronics is used to properly transfer power from the source to the load.